Hey everybody, Barry here again. I wasn't planning on working on the van tonight, but then a buddy of mine, Jonathan Wiseman, who's doing an insane K-swap turbo all-wheel drive Civic, which is insane, I'll say it twice. Anyway, he asked me about wastegates. He bought the exact same wastegate I did, which is like an eBay knockoff tile wastegate. And I had some questions on how to plumb it, how to get it to work correctly, and I figured why not do a video on it for him. So here we go. So I'm going to set everything up on the bench with the turbo, the wastegate, some tubing and stuff, and we'll get started on this video. I guess the first thing to talk about when you're trying to figure out how to plumb a wastegate is to know how the wastegate works. Here's our wastegate with the dump tube already on it because it was on the rat rod. This one's going to be situated kind of like this. So our exhaust comes up into the turbo, spins turbo, all that fun stuff. But when we get up to our max boost, we want to evacuate some of the exhaust pressure so it doesn't overboost the turbo. That's where the wastegate comes in. When the turbo has enough exhaust going through it to make your peak boost, it needs to evacuate some of the exhaust. And it does so by moving this plunger that we can see here back. That way the exhaust can go out through the wastegate, out through the dump tube, and away. So how that works is there's a plunger right here that stops exhaust flow so you can build boost. When it's ready, it'll open. And it does that using a spring inside to keep the plunger closed, along with a diaphragm that gets pushed open by boost. And I'll take this one apart to show you. And here's how it looks with it taken apart. So we can see our spring right here. Here's the cap with the top vacuum port on it. The diaphragm, this red piece around here, and the cup that the spring sits in that the plunger is connected to. With the spring out, it's easy to see that the plunger is allowed to travel up and down, or open and closed. Move it up here so it's easier to see. You can see here that the plunger is fully open, exhaust is allowed to evacuate out through this pipe, and calm down the boost. It'll maintain boost this way, because when you get your initial surge of boost, it'll open and it could potentially drop a little bit of boost, and then it'll sort of float in around where it needs to be to allow exhaust out. But the spring sits directly on top of the plunger and stops the plunger from opening with no pressure. If you didn't have this spring in here at all, the exhaust would just push the gate open, you wouldn't make any boost. So the spring wants to keep it closed like this. They're quite tough to compress. This one is a 5 PSI spring. I ordered a 10, but eBay, so I got a 5. As the spring is pushing the plunger closed, boost is trying to push the plunger open. Without a boost reference line on it from the turbo, it's not going to open when you want it to. A 5 PSI spring, I had them open at like 20 PSI and then spike, and then the boost freaked out. It didn't work. So that's why you need a reference line. The boost reference hose that's on the bottom of the wastegate is connected directly to the turbo in my application. So that when the turbo is producing boost, it'll also produce boost or pressure on the bottom of the diaphragm, which wants to push the diaphragm up. So with it being a 5 PSI spring, when 5 PSI of boost reaches this, it'll overcome the spring pressure, push the plunger open, and it'll maintain 5 PSI. Heavier spring requires more boost. A 10 PSI spring would make 10 PSI of boost. Now before I get into boost controllers and, the way of doing it correctly to make more boost out of a smaller spring, because a 5 PSI spring will make max 5 PSI, unless your wastegate is too small, then you get boost creep, whatever. But it does as it's designed to. And me wanting a 10 pounds of boost and got a 5 pound spring, I was like, I gotta fix this. Let's trick it. So I created a boost leak before the wastegate, meaning right here, seeing 5 PSI, up here seeing 5 PSI, I gotta leak some boost off. So this little Y connector, which is just a generic gas line Y connector, goes in line. And as the boost is increasing, 5, 6, 7, 8 pounds over here, a lot of that boost over here is leaking out. So you might have 5 or 6, 7 pounds right here, but as it's leaking off, you might only see 3 right here. So if you get where I'm coming from, with the 5 PSI spring, I was making, I think it was like 12 or 13 pounds. And when it got to the max boost that it could create, and the wastegate saw its 5 PSI, it opened, and I maintained 12, 13 PSI. Now, also, I did drill a couple of holes in this too, a couple 1/8-inch holes. And I made 15 pounds. Now, this is a real sketchy way of doing it. Like, I'm not going to say don't do it, because it worked fine for me. I didn't blow up anything until I got too spicy with the timing. But this is the backyard way of doing it. Working with what you got kind of thing. So that's just a little trick for anybody who wants to fool their wastegate. With a 10-pound wastegate spring, you could probably get 25 pounds or even 20 pounds. That worked really, really well. When going only gate or just with a boost reference here, leave this top port open because it needs to vent to atmosphere. Because as the plunger is opening, the top of this diaphragm, if it's sealed off, won't open. Because there's going to be positive pressure in here, and you'll need a whole lot of pressure to push this diaphragm up because this is all sealed. So you need it to push air out when the diaphragm goes up, and it needs to suck air back in when the diaphragm goes back down. So if you plug it, it's not going to move. Also, I should also look at, again, because I'm just doing this as I'm going, is there are multiple ports on the bottom of the wastegate. And what I found is that I think basically they're for ease of use. Because if I got something in the way over here, I can't use this port, so I'll use that one because there's 2. But you always have one blocked off, or if yours has 2 or 3, only have the one that you're using hooked up. Have the rest plugged like this. Because of course, if you've got boost coming in here wanting to push this gate open, and this is open, it's just going to blow it all out of here, and you're going to make some serious amount of boost. So let's get into 4-port boost controllers. I'm going to draw up a diagram. We'll check it out. Forgive me, this looks kind of crude. But here we go. This would be the MAC valve, or the 4-port boost controller. Here's the wastegate, lower port, upper port. This is not airtight. It's just conduit. And here's the boost reference hose to the turbo. So what we have here is the 4 ports. To the turbo, pretty straightforward, up to the reference pipe. It's always good to have your reference pipe directly off of the compressor wheel. That's where you get your most accurate boost reading. You can have it out here further, but people say pressure drop, all that stuff. Apparently this is about where it's best. Your lower port here comes into the wastegate, so you can see in a straight line that the boost goes directly across the solenoid into the lower port of the wastegate. This is what we were saying about boost pushing that plunger open. The spring is in there, of course, resisting forces. So say if you have a 10 PSI spring, just for a nice round numerical number, that, with everything disconnected, will make 10 PSI. Now here's where we get to our upper wastegate ports. So our upper, what I was saying before about having pressure up here, if you plug this off, it can't open. So it'll make more boost. So this takes advantage of it in small increments. So there's a solenoid here that will partially close off the upper wastegate port. You can see here that the wastegate port goes directly across and vents to atmosphere. If you make no changes, you're going to make spring pressure because, of course, you have coming in, pushing the valve open, opposing spring force across, venting out to atmosphere. So everything is just normal as it is. When the solenoid starts to close off, and I'll draw it just to make it simple, let's just treat it as a butterfly valve like that. As the solenoid starts to close this hose off, it produces a restriction so that it builds up pressure on the back side of this hose and resists some of the air coming out here, or the boost coming out of here. So as you resist it, it wants to hold this plunger closed. So you can do it in increments of, say, 1 PSI. So you close it a little bit, it'll make 1 more PSI because it's going to close that gate. It's only going to let so much air out. More boost. I don't think they close completely off because then I don't think it would actually ever open. But that's basically how it goes. Now, this one here goes out to your solenoid wire or your trigger, which would be controlled normally by the PCM or like a dial or a switch, or there's piles of different kinds. And you set your intended pressure based on, I think, your spring pressure. So you set, go beep, 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 up to 15 PSI, and it'll do its own magic, closing off the little orifices, and it'll make 15 PSI. That's the nice thing about boost controllers, is you can control the boost. It says it in the name. It's awesome. It's not a 5 PSI spring I reference where you're going to make 5 pounds. You can manipulate it a little bit and get 8, 9, 10 pounds out of it. Now, you are limited by your spring. You can't make 100 PSI off of a 5-pound spring. It's just not feasible, because after a while, your exhaust is just going to push that spring open and evacuate the boost. So I don't know exactly what the numbers are, but a 5-pound spring probably makes 15, 16 pounds on a boost controller. Maybe it might make more. A lot of people have more experience with this than I do and could chime in here and tell us. But a 10-pound spring is going to make a lot more boost, of course, than a 5-pound spring. So that's pretty much the gist of it. You can see a good overtop view here of how this works. Now, there are lots of different designs, but they are going to be labeled. Like, they might say lower port and upper here, and maybe, I don't know, turbo or boost or something like that, and then atmosphere. Or maybe it just has arrows. But that's one of the designs there. And if anybody has any questions on this stuff, how it works, you can absolutely ask away. If I can't answer your question, maybe somebody else can, and they'll chime in too. So it's all good. The car community is wonderful, and I love it. So I think that's about all the information that I can give on it. If you got any more questions, ask away. Like I said, somebody's going to answer it. Now, I'm not going to hook this one up yet because I'm not there. I don't have all the exhaust done. I don't have any of the plumbing done. There's a lot for me to do before I can hook this up. But my buddy asked a question, asked if I had a video on it, so why not make one? So thanks for watching, everybody. Have a good night.